Hello, Mr. Long, this is FRQ number 3. So, A asked to draw a free body diagram on M. So, here. This is the mass. So, pointing down is FG. Pointing up is FN. Pointing down this way onto the block, that is F. And there's mu k, so going this way, that is FK. Part B asks to refer the data in the table, so for A, so we know that x is equal to VIT plus 1/2 AT squared. VI is 0 because it's initially at rest, which means that x is equal to 1/2 AT squared. So we multiply 2, so it'll be 2x, and we divide by t squared, and that's equal to A. So vertical axis is 2x, and horizontal axis is AT squared. Oh, I mean, not AT squared, it's just t squared. So 2x, this is in meters, and t squared, this is in seconds. So 2x is 2 times this, so it'll be 0.072. This would be 0.468. Let me fix this, make it more legible. This is about 0.986. This is 1.458, and this is 3.042. So t squared, 0.2 squared is 0.04. 0.51 squared is 0.26. 0.74 squared is 0.55. 0.9 squared is 0.81, and 1.3 squared is 1.69. Part C asks to graph it and label it, so this is 2x, this is t squared. So time goes from, so this is 0, let's say this is 1.7. uh 1.36, 1.02, 0.68, and this is 0.34. Now 2x, I'm gonna round 2x down to 3. So 2.25, 1.5, wait, 2.4, 1.8, 1.2, 0.6, this is 0. So 0.04 is about here. 0.072. Zero 0.26 is about here, and then 0.468. 0.55, and 0.986. It's about here. 0.81, 'Cause it's like around here, and then the last spot is here. I'm just connecting the lines a little bit. The graph is something like that. Okay, part D asks to calculate an experimental value for that. So A of x is equal to about 0.072 over 0.04, and that's from the graph. You plug that into your calculator, you get A of x is equal to 1.8 meters per second squared. part D. Part E asks to derive it for the kinetic friction in terms of Fm. Okay, so net force is equal to MA. We know that A is 1.8, or we also know that net force F is equal to F in the x direction minus Fk, and that's equal to A Fk is the same thing as Fn mu k. Fx is the same thing as F cosine theta, and Fn in this case it's mg it's pointing down, so it's mg plus F sine theta, and that's equal to MAX. Oh, I forgot to add mu k. There's mu k. So I just have to divide everything. So mu k is equal to MAX subtract F cosine theta over minus mg plus F sine theta so mu k is equal to MAX minus F cosine theta negative so mu k is equal to negative MAX minus F cosine theta over mg plus F sine theta. Part F of this. Okay. So looking back from here, for part E, we now know that 12 newtons and okay, so mu, so this is Fk, so F cosine theta minus MAX, which is, and that's equal to Fk, because this is still the same thing as Fk. So you plug in the numbers, so it'll be 12 cosine 60 minus 2 times ax. Ax is 1.8. That's equal to fk. You plug that into your calculator. Fk is equal to 2.4 newtons. And this will be negative because it goes against the line of motion. Oh, that is part F. Part G asks to calculate the value for Fk. So okay, part F asks to calculate the numerical value of us using part F values. So we know that 12 cosine 60 minus 3.6 is equal to 2.4. And then this is the same thing as mg. Oh. We divide the mg plus f sine beta over. Then we plug them in. The mg is 2 times 9.8 plus 12 sine 60. You plug that into your calculator. Mu k is equal to 0.08. H. If the angle is decreased, then the acceleration so if the angle is decreased, then the acceleration would increase, because if we wait. The acceleration of the block will okay, so if the if the angle is decreased, then the acceleration would increase. The acceleration increases because as the angle decreases, then sine will get smaller and cosine will get bigger. And when the top number is higher, then the acceleration will be higher. Okay. So this is an A and T graph. You're asking to sketch. So the acceleration graph would stay the same. The acceleration is constant because nothing's being changed to make the acceleration different. This is 1.6, 2.0, 2.4, 0.6, 0.30, and this is 0.3, or yeah, 0.3, 0.6, and 0.9. This is the V of t graph. The velocity will increases at a constant rate. The velocity increases at a constant rate because the accelerates at a constant. No, the velocity is linear because the acceleration is constant. This is the x of t graph. So the x of t graph will be okay, the x of t graph will be a parabola because since the velocity is linear, that means that the position is increasing at a constant rate. Thank you for listening.